All right, so in lesson 6.6, we're going to kind of round out all of the quadrilaterals we're going to learn about. So in this lesson, we're going to learn about trapezoids and kites, and we are going to verify and use properties of trapezoids and kites. Now, these are the two least common quadrilaterals you're going to come across. Trapezoids are a little more common than kites, but I'm only going to focus on certain properties more and a few other properties less. So the first property we're going to talk about is property of trapezoids, and more specifically isosceles trapezoids. So before we go through anything else, trapezoids are quadrilaterals with exactly one pair of parallel sides. Those parallel sides are called the bases. So I want you to write this out. BC is a base, AD is a base. So the bases of a trapezoid are parallel. The non-parallel sides of a trapezoid are called the legs. So AB and DC are legs, all right? The legs of an isosceles trapezoid are congruent, just like the legs of an isosceles triangle are also congruent. So that's one feature of an isosceles trapezoid, is that the legs are congruent. Also, the base angles are congruent. The base angles are the angles that make up the bases. So A and D are base angles for base AD. B and C are base angles for base BC. So base angles of an isosceles trapezoid are congruent. Legs of a isosceles trapezoid are congruent. And the second theorem here kind of says the same thing. If a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. So if you see one pair of congruent base angles, that trapezoid is an isosceles trapezoid. So our first example is going to just be finding angle measures in trapezoids. So in example 1, CDEF is an isosceles trapezoid. The measure of angle C is 65. What is the measure of angle D? Measure of angle E? And the measure of angle F. So since this is an isosceles trapezoid, that means base angles are congruent, which means F is also 65 degrees. Now, the fact that these bases are parallel to each other, that means that angle C and angle D are supplementary. So angle D is 180 minus 65, which is 115 degrees. And since D and E are base angles that are part of the same base, E and D are congruent. So angle E and angle D are both 115 degrees. So in any trapezoid, these two angles, one from each base, are supplementary. So D and C are supplementary no matter if this is isosceles or not. E and F are supplementary whether that's an isosceles trapezoid or not. So next, I want you guys to work through the guided practice. It's the same exact problem, except I give you different angle measures in a different trapezoid. So pause the video, work through this, and then when you're ready, you can resume and check your answers. Okay, so for this example, pretty straightforward. R and S are base angles from the same base, so R and S are both 106. Q and P are the same measure. Q and R are supplementary, so that makes Q and P both 74. And in part B, it's just thinking about other situations. It says in example 1, if C, D, E, F were not an isosceles trapezoid, would C and D still be supplementary? And that's yes, because C and D are what we call, if you remember from a while back, they are same side interior angles. So they will be supplementary no matter if that's an isosceles trapezoid or not. So we're going to talk about a few more properties of isosceles trapezoids. One bigger one is a trapezoid is isosceles only if its diagonals are congruent. And we've talked about diagonals being congruent before, but that's just saying if this trapezoid is isosceles, BD and AC are congruent because they are the diagonals of that isosceles trapezoid. And then the mid-segments of an isosceles trapezoid. The mid-segment of a trapezoid, so I want you to remember the term mid-segment, is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So if MN is the mid-segment, that means that MN, and I know that equation's written out, but that means that MN is equal to AB plus DC divided by 2. We are going to use this equation to help us solve some problems later. So it's going to pay to remember that this mid-segment is the average of the bases. So that means you add the bases together, divide by 2, that's the length of the mid-segment. And that kind of makes sense because it should be a number in between the values or the lengths of each of these bases. So in our next example, example 2, QR is the mid-segment of LM and P. What is the value of X? So to explain this, I'm going to set up our equation. It means that QR is the average of LM and PN. So LM plus PN divided by 2, just to help illustrate that. So that means that X plus 2 is equal to 4x minus 10 plus 8 divided by 2. So I'm going to combine those like terms in my head. That becomes 4x minus 2 over 2 because I take 4x minus 10 plus 8. Negative 10 plus 8 is negative 2. So you've got different options when solving this equation. My opinion, what makes it easier for me is to multiply both sides by 2 because that eliminates 2 on this side, and I multiply the entire other side by 2. So this left-hand side of the equation becomes 2x plus 4 equals 4x minus 2. And once you have that set up, I'm confident you guys can solve that. So if I subtract 2x from both sides, this becomes 4 equals 2x minus 2. Add 2 to both sides, this becomes 6 equals 2x. So x is 3. And a really simple way to check your answers for a problem like this is to substitute x into each variable expression. If I substitute x into each variable expression, LM becomes 12 minus 10, which is 2. QR becomes 5, and that makes sense because 5 is the average of 2 and 8. 2 plus 8 is 10, divided by 2 is 5. So there's always a way to check your answers. In the guided practice, make sure you solve for x, but I also want you to find the length of MN and the length of PS. I know it doesn't say that in the directions, but it's good practice. So pause the video, work through this part or this example on your own. When you're ready, resume the video. I'll show you the answer. We'll go through the last example with kites. Okay, so 2x plus 11 equals 8x minus 2 over 2. Multiply both sides by 2. Solve it out to get x is 6. Substitute x into the expression for MN. Substitute x into the expression for PS. I get MN is 23. PS is 36. So we'll get some practice with this. Mostly, you're just going to have to remember a few properties and apply them on our next quiz. So I do still cover kites, but I don't cover them with as much of an emphasis as the other quadrilaterals, just because kites are a little less common. All right, we're going to come across them less. So there's a couple things I want you guys to know about kites. The first of those being that kites have 2 pairs of congruent sides. The thing that differentiates between kites and parallelograms, the pairs of congruent sides for kites are adjacent, meaning they are next to each other, not opposite from each other. Okay, so that's the first property of kites. The congruent sides are adjacent to each other. The other big property is that a kite's diagonals are perpendicular, which means they create a right angle where they intersect. The next thing about kites is that there is exactly only one pair of opposite angles that are congruent. It's always the 2 angles where 2 non-congruent sides meet, okay, where the non-congruent sides meet. C and A. So we're going to go through some examples of this, and I'm going to kind of help you kind of understand this, hopefully. Example 3, honestly, what I'm going to ask you to do for the kites is mainly find angles. And what helps to think of this as is that you can split this into essentially 4 right triangles, okay? So in this kite, the measure of angle 1, measure of angle 2, measure of angle 3. The first measure I'm going to find is the measure of angle 1, because I know from these properties we just talked about that the diagonals are perpendicular. That makes the measure of angle 1 90 degrees. All right? Makes the measure of angle 1 90 degrees. If the measure of angle 1 is 90 degrees, that makes the measure of angle 2 90 minus 52 degrees, which is 38 degrees. Sorry, I had to think about that for a second. 38 degrees. Because this is a right triangle right here. One of the angles is 90, one of them is 52. That means the other one has to be 38. So, knowing that, if you look at the triangle on the left, and I'll use blue for that one. This is also a right triangle. This angle is a right angle. We talked about a little bit about the angles. E and G would be congruent. So that means that this angle is 38, which kind of logically makes sense because then this angle would be 52. So in this kite, the non-congruent angles, this is kind of just an extra property, the non-congruent angles get bisected, okay? Just the non-congruent angles, not E and G, okay? The congruent angles don't get bisected. So once you go through more examples of this, you'll kind of pick up on some of the properties of kites, and that'll help. What will do that more is that you work through some of these on your own, and then with my help kind of on the side. So work through this guided practice. Once you're done, I'm just going to put my answer up on the screen. You're going to check over it, then you can move on to the next step of the lesson. So to finish out these notes, measure of angle 1 is 90, diagonals are perpendicular. Angle 3 and this 36 degree angle are congruent, so angle 3 is 36 degrees. Angle 2 is 90 minus 36 degrees, which is 54 degrees. So mostly remember with kites, I'm going to ask you to mainly find just the measures of angles in kites, just to split it up into different right triangles. That's the main thing. Trapezoids, there's going to be a little bit more to it, but I'm going to give you a graphic organizer later to help you kind of remember the properties of trapezoids also. So you can move on to the next step in the lesson.